Hello everyone, welcome to the routing lab session. In order to continue with the lab session, I want all of you to download the basic file that you can see here, the packet tracer file, without any IP assignment. You can download it from the course set and open it up. So we are going to working on this particular diagram in order to get our attributes and certain components that we are going to configure. Even though this lab specifically focuses on routing, I have included the VLAN and the VTP part that we have done so that you can recall your memory. In addition to that, I have added the VLSM in order for you to recall your memory about subnetting. So let's get to configuration. So let's discuss about this network for a bit, then you will be able to understand what sort of a configuration that we need to do. Now this is an example of a certain organization. In this organization, there are three main sections. Let's call them branches. So in the left side, connected to R1, router 1, we have our head office. This is the head office. Head office contains three main departments. So we have student, HR and admin. The bulk is for random usage. You can assign any unused ports or unused host into bulk until they get a proper department. And these departments should be created in a form of VLANs. So for the students, we have VLAN 101, which contains 110 PCs. There are 110 students. And for the HR, we have VLAN 102, which requires around 20 hosts, 20 PCs. And VLAN 103 for admin, which requires around 5 PCs. And in order to distribute this information among all of these switches, one way is to configure all of these VLANs one by one in each switch, switch 1, 2, 3 and 4, which will take a long time. But we have learned that there's a protocol called VTP, VLAN trunking protocol, in order for us to populate this information. So that's why I have marked switch 1 as the VTP server, switch 2, 3 and 4 as VTP client. I have given you a VTP domain of TCP. After you configure all the trunk ports, we will be able to create all the VLANs in one switch, which is switch 1, and the switch 1 will send this information to all other switches. And then we need to make sure that we assign each and every PC to correct VLAN. For example, this is HR, this is admin and this is student. We need to make sure these VLANs can communicate with each other. So we need to configure this router with sub interfaces with IEEE 802.1 encapsulation, and we need to configure the default gateways. So that's our head office. And we have branch 1, which I have given you a separate block 172.17.17.0/24, which means this branch 1 can hold up to 254 usable IPs. And we have the server farm, which has only 2 servers at the moment, and it has a block of 200.2.2.0/29, which means we have 6 IPs that we can work with. The WAN between R1 and R2 is using 202.20.20.0/30. /30 means you need to understand there are only 2 possible usable IPs, 202.20.20.1 and 2. So we'll assign 1 to serial 00 of R1 and 2 to serial 00 of R2. Similar story here. The network between R2 and R3, we need 2 IPs for the serial 10 of R2 and serial 10 of R3. For that we have /30 network. So the only 2 possible IPs from this block will be 202.20.20.129, which will assign to serial 10 of R2, and 130, which will assign to serial 10 of R3. So this is our network. And after you configure all of this, we need to make sure they can communicate within anywhere within this network. To do that, we need to enable routing, and let's use a routing protocol like RIP version 2 or EIGRP in order to get this work done. So let's go ahead and start our configuration. I'm going to start by subnetting according to our requirement. Now we have a requirement given here. So let me take a note and indicate this. For the VLAN 101, which is students, that's the largest requirement. So we have 110 PCs, that means we need to have 128 PCs, because that's the closest value, that's a power of 2. So if you are giving 128, the starting block is as 192.168.122.0, so it should be 192.168.122.0/25, because we are taking 128. Let's do the same thing for the 102. So 102 is HR. Since we have our requirement is 20 PCs, 20 means 32. So since we need 32, we can give 32 from 128. So the starting network address will be 128, and this becomes 27. And then 103, which is admin. Requirement is 5 PCs, that means we need to get 8 PCs. So 120 plus 32 becomes 160, so the starting address is 160, and from there we are getting IPs. So these are the blocks for the each VLAN. Let me make it streamlined so you can see this nicely. This is what we have. And for the default gateways, I'm going to use the last usable of each block. So the last usable of this particular VLAN students is 192.168.122.126. That's the last usable. Let me write that as well. So the last usable of this one will be 126. That's the last usable. What about the second one? Well, last usable of second one, which is HR, is 158, and last usable of admin is 166. Now we have last usable IPs as well. Let me make it streamlined so it's clear to you. So we are going to use this last usable as our default gateways. So let's go ahead and configure. So first of all, I'm going to configure the switching. So starting with trunk ports. Now if you consider switch 1, there are two trunk ports. The port pass Ethernet 0/1, which is connected to router 1, is a trunk port, and the port which is connected to switch 2, 1/1, is also a trunk port. The rule is, if a switch is connected to another switch, both side ports are trunk, and if a switch is connected to a router, the switch side port will be a trunk port. So pass Ethernet 0/1 and 1/1 both are trunk. So let's go to the CLI. Let's go to the global configuration mod. So the command, I'm going to select both interfaces using range command. So interface range pass Ethernet 0/1, pass Ethernet 1/1. Both of these interfaces should be switch port mode trunk. So So this command will make sure both of these ports are turned into trunk ports. And I will do the VTP configurations with this as well. So VTP mod, it's server. Actually I don't need to issue this command because it's already a server. And I will set the VTP domain. Domain name is given as TCP in simple letters. So I'm going to type the domain name to TCP. Right, let's go to the switch 2 configurations. So there are a couple of trunk ports here as well. The pass Ethernet 1/1, pass Ethernet 0/1 and pass Ethernet 2/1. All of these ports are trunk ports. So let's do that very quickly. Pass Ethernet, this is range command. That's quick. So pass Ethernet 0/1. Actually here the 0/1 port, it's already been converted into a trunk port. Reason, when I made this pass Ethernet 1/1 in switch 1 to trunk, it has something called the auto negotiate. That means this switch will communicate with switch 2, and since the pass Ethernet 1/1 is a trunk port, it will automatically negotiate with pass Ethernet 0/1 and make it a trunk port. Nevertheless, we don't want to rely on that. We will just issue it for all the trunk ports. So 0/1, 1/1 and 2/1. Okay, they should be switch port mode should be trunk. So let's make it a VTP mod. This is a client one, so I'm going to make it client, and VTP domain I'm going to set to TCP. So you can see domain name is already set to TCP because the switch 1 has already sent this information to switch 2. So let's go to switch 3 and do the same. Now here we have 0/1 and 1/1 as a trunk port. So let's go ahead and make them trunk as well. Like I said, if the auto negotiate is working, 0/1 should be already a trunk port. Nevertheless, we will issue the command 0/1, pass Ethernet 1/1, both are trunk ports. And then make sure VTP mod is set to client mod and VTP domain is TCP. You can see here also domain name is already set to TCP. Let's go and continue this for switch 4 as well. So in switch 4 we have 0/1, 1/1 as trunk ports. They should be trunk automatically. You can see in the messages right here as well because of the auto negotiate. Nevertheless, we will issue the command. So interface range pass Ethernet 0/1, pass Ethernet 1/1 should be trunk. You can see there's no message coming in because they are already in trunk mode. And we can say VTP mod is client and VTP domain is TCP, which is already set to TCP. Now we have all the trunk ports and the VTP configured. Now the best part is, if you create your VLANs on the VTP server, it should send this automatically to other switches. So at the moment, if you just randomly open switch 3 and if you exit to the privilege mode, if you issue the command show VLAN brief, the short command is shblbr, and press enter, you should see there are no VLANs except for the default one. Now this is true for any switch on this particular network because we haven't created any VLAN. So show VLAN brief will reveal that there's no VLAN except for the default one. But if the VTP is working properly, if you create all the VLANs right here, they should be propagated or transferred to all the switches here. Let's do that. So I'm going to go to the VTP server, which is switch 1 with the global configuration mod. Sorry about it. Okay, and let's create our VLAN. So VLAN, the first one is 101. name of this VLAN is student. Next VLAN is 102, name is HR, and VLAN 103, name is admin. And we have another VLAN to create, which is VLAN 999, the name is bulk. So we have created the 4 VLANs in the switch 1. And now if you exit to the privilege mode and issue the command show VLAN brief, you should see these additional 4 VLANs are created, and they should be created in all of these other switches as well. So if I go to switch 4 and issue the command show VLAN brief, you should see these 4 VLANs are here also. So they are in all the switches. Now we can go ahead and apply these PCs into the correct VLANs, but we need to assign the IPs first. So let's go to the HR PC, desktop IP configuration. Now we know for the HR we can assign any IP from 192.168.122.1292 to 158. You can assign any IP in that range because we have subnetted our VLSM answers are giving that answer. So it's 192.168.122. I'm going to assign the first usable, which is 129. So this is a 25 network, sorry 27 network. So the subnet mark should be 255.255.224. And the gateway, I'm going to use the last usable as the default gateway. It should be 192.168.122. The last usable is 158. That is also there. Okay, let's go ahead and configure the admin PC. So admin PC, the range is 192.168.122.161 to 192.168.122.166. You can assign any IP there except for the last one, because that one will be default gateway. So we'll assign the first usable, which is 161. Now this is a sorry, I made a mistake. It's a 29 network right here. It's a 29 network. So it's 255.255.255.248, and the last usable is 166. That's our last usable. Let's assign IP for the student PC as well. The student PC can range from 1 to 126. It's a 25 network, so it's 128 right here. And the default gateway will be the last usable, which is 126. Okay, now let's put them to correct VLANs. Fast Ethernet 3/1 on switch 2, which is connected to HR PC, should be accessing the HR VLAN. Let's go to switch 2. Let's go to interface Fast Ethernet 3/1, which is right here. It should be HR. So switch port access VLAN. HR VLAN number is 102. Now let's do the same for the other switches. Now in the switch 4, we have interface Fast Ethernet 2/1 right here, should be admin. So switch port should access VLAN. Admin VLAN number is 103. In the similar way, interface Fast Ethernet 3/1 should access VLAN 101 because that's student. Okay, now we have assigned these PCs to their correct VLANs. Now what you have to do is we have to configure sub interfaces, encapsulation .1q, that means IEEE 802.1q encapsulation on this fast Ethernet 2.0 interface. That means we have break it into sub interfaces. We need 3 sub interfaces, 101, 102 and 103. Let's go ahead and do that. Go to router 1, CLI. Let's go to the global configuration mod, and we are going to start with the first interface. So interface fast Ethernet 2/0, because this is 2/0 dot 101. This is for the students. I'm going to use encapsulation dot 1q 101, and the IP address for this one is the last usable of the student, which is 192.168.122.126. So it's 192.168.122.126. It's 255.255.255.128 because it's a /25 network. Let's go to the second sub interface. It should be 102. This is for the HR. So encapsulation dot 1q 102, and the IP address is 192.168.122. The last usable of HR is 192.168.122.158. That's our broadcast address, and it's a 255.255.254 because it's a 27 address. And let's create the last one, last sub interface. It's 103. This is for the admin, and let's use the encapsulation on 103 as well. So IP address is going to change into 166. That's the broadcast last address of admin, 166 last usable address, which is 255.255.255.248 because it's a 29 network. Okay, now we have our 3 sub interfaces created, 101, 102 and 103. Now let's turn on all the ports. You can't turn on sub interfaces separately. You need to go to interface fast Ethernet 2/0 and turn it on. Let's go to interface fast Ethernet 2/0 and issue the command no shut. It's a short command for no shutdown. Once you enter, all the ports will be turned on. Let's see, 101, 102, 103 and main interface has been turned on. Now you can see this is ready to communicate, and it's turning on. Let's give it some time, somewhere around 30 seconds, until this port becomes green color. That means it's in the forwarding state. Then you should be able to send a message and connect. So let's wait a couple of seconds more until this comes to forwarding state. Okay, now it's in the forwarding state. Now let's send a couple of messages and see whether it's working. So HR to admin, we have to send a couple of messages. It says successful. That is what we wanted. Maybe from student to admin, successful, and all of these PCs will be able to send messages to the router R1, successful, from admin to R1, successful, and from student to R1, successful. Okay, so let's go ahead with the other configuration very quickly. I'm going to start configuring branch 1 because my head office configurations are correct, and it's done. Let's go to the branch 1. So it's very easy, there's nothing to configure, no VLANs. So I'm going to straight away assign the IPs for the branch PC1. So the given IP is 172.17.17.0/24. So I'm going to use the first usable, which is 1, and it's 24 network, so it's 255.255.255.0, and the last usable will be used for the default gateway. Last usable of this block will be 254 because it's a /24 network, and use the same thing on the branch 1 PC2. It's a second usable IP. It's 255.255.255.0, and the default gateway remains the same, 172.17.17.254. Now we need to assign the gateway to the fast Ethernet 20 of this router R2. Let's go to router R2. So I'm going to go to interface, fast Ethernet 2/0. The IP address for this one, it's 172.17.17.254. It's 255.255.255.0. And let's issue the command no shutdown to turn it on. So this port will be turned on, and you should be able to send message from branch 1 PC1 to branch 1 PC2. Let's send a couple of messages. Branch 1 PC1 to branch 1 PC2, it says success. And you should be able to send a message from branch 1 PC2 to branch 1 PC1, that's also success. Let's go ahead and double check whether we can send a message from this branch 1 PC1 to router 2, and also branch 1 PC2 to router 2. In order to do that, we have to wait until this fast Ethernet 0/1 becomes green. Like I said, it takes around 30 seconds for a switch port to go into forwarding. Okay, now it's green color, forwarding state. So we'll send a message from B1 PC1 to router 2, successful, and we will send a message from B1 PC2, branch 1 PC2 to router 2, success. Okay, that's part branch 1 is also working. Let's quickly configure the servers. So again, I can configure the IP addresses for the web server. Let's go to the IP configuration. Given IP block is 200.2.2.0/29. That means I can use 1, and it's 255.255.255.248 because it's a 29 network. Sorry, 248. And the last usable is 200.2.2.6 because it's a 29 network. Let's assign the same thing for the SMTP server. Use the second usable, same subnet mask and the same default gateway. So this address should be assigned to fast Ethernet 20 of R3. Let's quickly go to R3. I'm going to go to interface fast Ethernet 2/0, and I'm going to say IP address. It's 200.2.2.6, and it's 255.255.255.248. Let's issue the command no shutdown. Okay, now you should see you can send a message from SMTP server to web server, and from web server to SMTP server as well. Alright, and also double check once this becomes green color whether you can send a message from SMTP server to R3 and web server to R3. You have to wait until the port becomes 4. Now we have all three branches configured. We have the server farm configured, we have the branch 1 configured, and we have the head office and its VLAN configured. And all of these hosts can communicate with their respective routers. Now we need to configure our WAN links as well. And we have WAN 1 right here, a connection between R1 to R2. So like I said, we have two IPs from this block, 202.20.21 and 2. I'm going to assign 1 to here and 2 to here. So let's go to R1, and let's go to interface serial 0/0, which is right here, and I'm going to assign the IP address 202.20.20.1. It's a 30 network, so it's 255.255.255.0, sorry, 252. And I need to set the clock rate because this is a serial interface. You can see the clock icon. So clock rate, I'm going to set this to 64,000. And now I can issue the command no shutdown. Even though I issue the no shutdown command, you will notice that this particular port doesn't turn on. Reason, if a router wants to turn on a serial interface, it should be turned on from the both sides. That means when I turn on the port from the R2 side, then only the port will become active. So we'll do that very quickly since we have assigned number 1 here. Let's go to R2. Let's go to interface serial 0/0, IP address, it's 202.20.2 20.2, 255, 255, 255.252. And there's no need for me to set the clock rate. I'm just going to turn the port on. As soon as you do that, you can see both of these ports are turning on. And also verify whether you can send messages from R1 to R2. Send one again, R1 to R2 successful, and again from R2 to R1 should be successful. Alright, let's do the same for the R2 and R3 WAN as well. I'm going to go to the R2 again. So this time I have to go to interface serial 1/0, which is the port right here. So the block is 202.20.20.128/30. That means we have two IPs, 129 and 130. So I'm going to assign 202 dot, so an IP address 202.20.20.129. It's 255, 255, 255.252. Because this is 30 network. And I have to set the clock rate here as well because it's a serial DCE interface. So let's set the clock rate to 64,000 and no shutdown to turn it on. Let's configure the other side as well, which means the router 3 serial 10. So interface serial 1/0. IP address should be 202.20.20.130 because 129 we have assigned to the side, 130 is the only available IP. So it's 255.255.255.252, and we can issue the no shutdown command. Okay, so that's also interface up. Now you should be able to communicate between R2 and R3. Let's double check that. A message from R2 to R3 successful, and R3 to R2 successful. Okay, now you can see all the ports in this network are turned on. So let me verify that. If I want to send a message from HRPC to R1, I can. And if I want to send a message from R1 to R2, I can. And if I want to send a message from R2 to R3, that's also I can. If I want to send a message from R3 to SMTP server, let's send another message R3 to SMTP server, I can. So you can see I can send a message from one end to another end. However, if I want to directly send a message from HRPC to SMTP server, it doesn't allow me. If I try it again, HRPC to SMTP server, I can't. Reason, routers, even though they can directly communicate with the network which is directly connected, they can't pass that information to the other end without the help of a routing protocol which you have learned in the theory. For example, R1 can forward the message without any problem to R2, but R2 can't forward it to its own network without knowing about the destination and the source addresses. So in order for this R1, R2 and R3 to communicate with each other, they need to be configured with something called a routing protocol. And we know in our syllabus we learned about the RIP version 1, and we talked about EIGRP and RIP version 2. So I'm going to look at EIGRP and RIP version 2 both. So I'm going to save this network at this point, and I'm going to open up another file. I'm going to save it as routing, let's say RIP version 2. So that's EIGRP. Okay, and I'm going to save another copy of this to RIP version 2. So I can show you how both of these protocols work. So let me show you how the RIP version 2 works. The idea is simple. We need to introduce the directly connected networks to all of these routers, and they will do the rest automatically. They will communicate with each other automatically. So what are the directly connected networks for R1? Now if you think about it, we have how many networks? One, we have a directly connected networks, which means 202.20.20/30. This is the directly connected network to R1 right side. What about the left side? In left side, we have several VLANs. So each VLAN becomes a separate network. So in that case, we have 192.168.122.0.25, that's one. 192.168.122.128/27, that's one. 192.168.122.160/29, that's one. So how many directly connected networks again? We have 4. We have 3 for the each VLAN and 1 for the WAN. Let's introduce that in the R1. So I'm going to go to my router. In the global configuration mod, you have to issue the command router RIP, and the next line you have to say version 2. If you are using version 1, there's no need for you to issue this version 2 command. You can just continue with our router RIP, and then you have to list down the directly connected networks. So network, so first one is 202.20.20.0, this is one, and then again second network. So we have 3 networks actually, 192.168.122.0, and the third network 192.168.122.128, and we have 160. So we have 4 networks directly connected to R1, the 3 VLANs and the WAN link. That's it. So router initial network discovery has turned on. We will do this in the router 2 as well. We have to go to router 2 and introduce it to the directly connected networks. Let's go ahead and do that. So I'm going to go to router 2. Let's go to the global configuration mod, and you can say router RIP version 2, and we can directly list down. So how many networks are connected to R2? So we have on the left side we have 202.20.20.0 network, and on the right side we have 202.20.20.128 network, and in the bottom we have 172.17.17.0 network. So we have 3 directly connected networks. Let's list down them. So network 172.17.17.0 is one. Network 202.20.20.0 is one, and network 202.20.20.128 is one. We have 3 directly connected networks to router 2, and we have listed. Now we're done with that. We can move on to the router 3. In router 3 we have again 2 directly connected networks, one the server farm 202.2.0 and 202.20.20.128 the WAN link. Let's go to the router 3 and let's go to the global configuration mod and say router RIP version 2 network. We have 202.2.0, and we have network, the WAN link, which is 202.20.20.128 network. Sorry, I have done a spelling mistake, sorry about it. It's network right here. Okay, so let me type that very quickly again. RIP version 2. So we have the 202.2.0 network, and we have 202.20.20.128. This is for the router 3 router configuration. Alright, now believe it or not, these routers are communicating with each other. I will show you in a bit how that messages are going in, but they are communicating. That means you should be able to send a message anywhere within the network. Let's try and see. So I'm going to send a message from HRPC. Previously I was trying to send one from HRPC to SMTP server, which was a failure. But now you can see I can send from HR to SMTP server successful. Let me show it again. SMTP server to HRPC successful. And if I try from branch PC1 to web server, you have to send a couple of times, 2 times maybe, branch PC1 to web server success. And student PC to, let's say, branch PC1 successful. Now you can communicate anywhere within this network because RIP version 2 routing protocol is communicated, and they work constantly like we discussed in the theories in order to get your work done. Okay, I'm going to open up the same diagram. I'm going to save this and I'm going to open a different diagram, which means same diagram I have saved, EIGRP. So we are back to the part where we have the routing is not configured, RIP version 2 is not configured, but rest of the IPs and everything are configured. So we will give 30 seconds for these ports to go on forward. So 30 seconds is the time limit. Reason, a switch port, one of the switch port can be in 4 states. It's either listening, learning, forwarding or blocking. So when you start the switch for the first time, all the ports of that particular switch goes to the listening mode. Spends around 15 seconds in listening, and then they go to learning, spends around another 15 seconds. Then everything is okay, they go to forwarding state, or they go to blocking state. I can see all the ports are turning into green color. Now instead of RIP version 2, I'm going to configure EIGRP. So let's go to R1. Only difference between RIP version 2 and EIGRP is that we are using something called the autonomous number. So the command is, the previous is router RIP, in this time it's router EIGRP. You can see it says incomplete command. Like I said, in order to use EIGRP, we have to use a number. This number is known as the autonomous number. Now autonomous number means it's a random number to indicate to all the routers that they belong to the same domain. So in this particular lesson, since all these routers are 1, 2 and 3 belong to the same network, same organization, I'm going to give the same autonomous number. Now this number can be anywhere between 1 to 65,536. So you can select any number that you want, but make sure to use the same number on all the routers. So I will issue the command again. So it's router EIGRP. Let's use 100 as example. You can see your prompt is changing from config to config route. Now just like before, I can say network and config, but there is a small issue. Now there's something called network summarization. Network summarization means when you issue the network address, your router protocol, basically RIP version 2 or EIGRP, is basically summarize that information into classless and classful IPs. In order to prevent it, sometimes it can be problematic, especially if you're using VLSM, you need to make sure the summarization is turned off. How to do that? You can type the command no auto summary. Now no auto summary command will make sure there's no summarization available, no auto summary. Just enter that, and then you can, just like before, network and list down the directly connected network. So the like we discussed, R1 has 4 directly connected networks, 1 for each VLAN and for this WAN link. So I'm going to go ahead and type those. The first one is 202.20.20.0. Now previously I didn't enter my subnet mask. Now in this EIGRP you can type 255.255.255. It's a 30 network, so 252. That's the difference between RIP version 2 and EIGRP. You have autonomous number, you turn off the auto summarization, and you enter your subnet mask along with the network address. Okay, the second network is 192.168.122.0/25, which is the student network. So the subnet mask is 255.255.255.128, and then have the same address, but it's not 0 anymore, it's 128, and it's a 27 network, so this becomes 224. And lastly, I have the admin network, which is starting with 160, and this becomes 248 because it's a 29 network. So that's the EIGRP configuration for router 1. Now let's go ahead and configure the EIGRP for R2 and R3 as well. Okay, so router EIGRP, same autonomous number 100, and say no auto summary. Network, so we have again 3 directly connected networks to R2, which is 202.20.20.0, it's 255, 255, 255.252. You can see, as soon as I enter that command, now our router R2 realized that R1 is using the same network address, and it automatically immediately recognizes as new adjacency. It means a new neighbor. So this is what we discussed in the routing lecture. If you can remember, I told you EIGRP is immediate. It works with triggered updates. So immediately it recognizes. Let's enter the second one, which is 202.20.20.128. It's a 252 network, and then we have network 172, the bottom one, 17.17.0. It's a 255, 255, 255.0 network, and those are the 3 networks, directly connected networks to R2. And quickly we will go to R3 and configure it as well. So R3 has again 2 directly connected networks. Okay, so router EIGRP 100, we have turned auto summarization, so no auto summary. The network, now the first network is 202.20.20.128. As soon as I enter this command, R3 should recognize it as a neighbor adjacency because it shares the same network. So 202.20.20.128, which is bearing the subnet mask 255, 255, 255.252. You can see it recognizes the neighbor. And the last network is 200.2.2.0/29, that means it's 255, 255, 255, 248. Now we have configured EIGRP for all the 3 switches. Let's see, routers. Let's see whether we can communicate. Now if I send from HRPC to web server, send. Okay, you can see successful. Now let's try from SMTP server to student PC. SMTP server to student PC, successful. So likewise, you can communicate anywhere within this network now without any hassle because EIGRP is working. Okay, now to the final stage. How these updates are working, how these routers are communicating. In order to view that, let me open up 2 routers simultaneously. I'm going to open up R2, and be careful when you're doing this because you might not be able to stop it. So make sure that you type these commands on a notepad and then paste it to the console of R2 if it is difficult for you to stop. So I'm going to turn on something called the debugging. That means it's going to show me the messages these routers are communicating with each other. So So I'm going to go to router 1 R1 and I'm going to turn on something called debug. So to do that I can say show IP EIGRP. So I can have couple of options here. I can have interfaces, neighbors, topology, traffic. Okay, if I say traffic, I can see the traffic which is sent from each router. You can see a number of hello sent, update sent and received, queries sent and received, ask, acknowledgements received. So these are the messages that have been sent between these routers. If you want to view this in real time, you can type the command debug IP EIGRP summary. The command is debug IP EIGRP summary. If I turn this on, auto summary debugging is on and you will see the information flowing through these routers. So let me show you how this works. Now I have turned on the debugging on R2. I'm going to open up the R1 side by side. So I have R2 and R1 both. Okay. Now if I turn on or turn off a network, EIGRP should immediately inform that, isn't it? For example, if I turn off fast Ethernet 20 port right here, it should inform to the R1. R1 should inform that change to R2. Let's see whether it does. So if I go to fast Ethernet 20, this is the port. Okay. If I go to command from CLI, it's a interface fast Ethernet 2/0. If I issue the command shutdown, so I have turned off the port and this information should be sent to the other side. So we'll issue that command, the traffic statistics. We got the statistics here 81, 88, 51 and should be increased. So I will issue the command show IP traffic. You can see it has been increased to 134. Okay. Right. Now, since the debugging is on, I will close this and I will turn on the port back to normal, which is fast Ethernet 20, turn in and make sure that I get that information here. So if I issue that command again, traffic, you can see that number has increased more because there are so many messages going back and forth between these routers. So this is what is routing, is known as routing. So we have configured RIP version 2 and EIGRP. I want you to complete this diagram which is available for you to download, not the full version. You have to configure it and try it and make sure you bring this up to the 100% working packet tracer diagram, because you can expect something similar for your online examination too. So we'll wind up the lab session.